Good day. Welcome once again to another session for our mathematics live class. Now, last week or last session, we started a topic of mathematics that is very interesting. A topic that encompasses what it is to take advanced mathematics, at least in its rudimentary level, as well as every single possible concept that makes up the combination or composition of mathematics at an advanced level. We started the concept of calculus. We are going to continue that concept today. Now, under calculus, we explained last class that we have two broad concepts or two broad areas in calculus. We have the concept of differentiations and we also have the concept of integrations. We looked at the fact that if you consider the concept of differentiations and the concept of integrations, you can call them reverse processes of one another. That is, whatever process you complete with differentiation, you can reverse that process by taking the integration or the integral of that result. We are going to see how this works when we begin to take both of them in tandem. But for now, we are still talking about the concept of differentiations. We looked at basic differentiation of different kinds of mathematical functions that could exist. We looked at the algebraic function. We looked at the exponential function. We looked at the logarithmic function. We also looked at the trigonometric function. We also looked at how we could extend different kinds of differentials based on this concept. We rounded off the session last time with a look into the concept of product and quotient rule. We talked about the quotient rule as coming from when there is a division of two kinds of mathematical functions that we have to differentiate, and we looked at the product rule, which comes as the multiplication of two kinds of functions that again we have to differentiate. Of course, in today's session, we are still going to put much more emphasis on these two kinds of functions or these two kinds of rules while still extending it into something very new. We are going to be looking at all of this in detail. All right, so let's continue. Now, before we go back into exploring the concept of product rule and quotient rule, we must first and foremost understand that even though we talk about the multiplication of different kinds of functions, such that when we differentiate them, we have to spend some time using some particular kind of method, the underlying differentiation we carry out does not change. We are still using the simple basic methods of differentiation. And that is by taking the first term or the original function and operating on that original function based on different kinds of frameworks that exist. Let's quickly run through the different kinds of frameworks that we talked about. We talked about first, so we are still under differentiation. We talked about the framework for the algebraic functions. And we said that we could express a general form in y equal to ax raised to the power n. And that if we were to differentiate this, either we write it as y prime or we write it as dy dx, either one is fine. Then the differentiation of this algebraic function simply takes us multiplying the power by the coefficient, rewriting the function, and then subtracting 1 from the power. So the differentiation of ax raised to the power n simply gives us nax raised to the power n minus 1. Power multiplied by coefficient, subtract 1 from the power. Simple and short. That is the underlying principle for differentiation of algebraic functions. We talked about logarithmic functions. Now, when we say logarithmic functions, we are talking about functions in the natural logarithm sense. So we have y is equal to ln f of x. And we said that when we consider the logarithmic function of any kind of function, the differential is simply differentiate this inner function. So that's f prime of x, and divide it by the original function, f of x. This is all you are doing. This is the process for differentiation of logarithmic functions. Differentiate the inner function divided by that inner function itself. Then we looked at the concept of the exponential function. It is very important to have a very grounded knowledge on all of this before we start to build mansions on this. If the stones of the foundation does not sit well, then regardless of any kind of structure you put on it, the house is set to crumble. We have y is equal to e raised to power f of x, and we said if we are to differentiate this, we will have this as differentiating the power, which will give us f prime of x multiplied by the entire exponential function. We looked at all of this in our last class. We also talked about the trigonometric function, and we said the trigonometric functions are very unique functions in that they follow a simple pattern. However, the pattern changes for each trigonometric function. So if you have y is equal to sine x or sine f of x, the differential is simply going to be differentiate that inner function, that does not change, f prime of x, multiply this f prime of x by the differential of sine. Now, whenever you differentiate sine, you will have cos. So that's cos f of x. Right? So when you did the trigonometric function, you are still multiplying the differential of the inner function by the differential of the trig function itself. So whenever you differentiate sine, you will have cos. What happens when you differentiate cos? When you differentiate cos, you will have minus sine. Hence the reason why there's a minus sign here. So whenever you differentiate cos, you will have minus sign. Differentiating the inner function gives you f prime of x, and that remains. Similarly, if you have y is equal to tan f of x, then differentiation of this will simply give us sec squared f of x. Do not forget, this is incomplete if you write it like this, unless you put in f prime of x. So you must always remember to differentiate the inner function in all cases, right? So we looked at all of these functions. And then whenever you even carry out products of functions or divisions of functions, and then you have to use the product rule or the quotient rule, you will find out that you still have to use these underlying methods in order to carry out your processes. Let's take quick examples on the product rule and the quotient rule so that we are refreshed on our memories for these major terms that we need before we now begin the day's journey. So we still have space. Our product rule. We said that for the product rule, we can define when we have y to be equal to, do not forget that when I'm writing y, it's still the same thing as me writing y of x. That is completely the same. And this is, let's say this is equal to the product of u and v. Then what are we saying? If I take the differential, this is simply u dv dx plus v du dx, which means hold u differentiate v plus old v differentiate u. That is the simple process for product rule. Now let's see how it works in practice. Example, let us quickly differentiate x squared sine 2x. Let us differentiate this quickly. Now you see that you have two distinct functions. We are not talking about the function of functions, which is a function that is embedded in another function. We are not talking about that. For instance, if you were to look closely at sine 2x, this is a function of functions. It contains 2x, which is an algebraic function, but this 2x is completely embedded in the trigonometric function sine. So this will still be referred to as one single function. For instance, you as a child, you stand alone quite all right. However, you are still embedded in your nuclear family. That is in the family consisting of your father, your mother, your siblings. You are a constituent of that family. That is still one single family, right? However, the moment you now consider yourself and your family, and then pick a consideration with a classmate of yours, then that becomes two distinct families because your classmate is not a member of your own family. your classmate will have his own familial relationships, which means that you two are distinct, even though both of you are still humans. So x squared is very, very distinct than this 2x that is standing in this position. Even though they are both algebraic functions, this 2x is embedded in a trig function. So we would essentially say this entire function is a trig function, because regardless of whether it contains an algebraic function, it has been embedded in a trig function, so it's a trig function. And then this one is simply an algebraic function. So you say you have a product of functions when there can be two distinct functions you can find. When those two functions do not meet or do not mix, or there is no possibility for you to combine them, then they are distinct enough for you to solve them via the use of the product rule. Now, how does the product rule work? This is very, very important. We pick one of the functions and term it as u. Any of the functions. This is your own choice now. Then we pick the other function to be v. Then we differentiate u and v respectively. So we'll pick du dx, and that's the differentiation of x squared. This will give us 2x. Just apply the functions for the algebraic functions we have run through. And then we have dv dx, which will simply give us 2 cos 2x. Just run through the trigonometric function we have talked about. Next, we look through the product rule. By product rule, we see that this function, if we term it as y to be equal to x squared sine 2x, then dy dx will simply be u dv dx plus v du dx. And this means that we are holding u, which is x squared, into the differential of v, 2 cos 2x, plus v, which is sine 2x, into du dx, which is 2x. And then we'll have this as 2x squared cos 2x plus 2x sine 2x. Final result. Of course, you could still move further and say, let's carry out the factorization of this function. That will be completely acceptable as well. Remember, the continuous process of simplification will depend on what you have in your options. Remember, if it's a multiple choice exam, then you differentiate or you simplify to the extent to which you have your answers in the options. If it's a theoretical exam, then you are expected to simplify to the barest minimum. Why? Because every single stage you use in simplification will earn you marks. Each of those stages will be given marks and will be accounted marks for, which means the extent you stop will be the extent you will be given marks for. If you continue beyond that level, then you have marks for those new levels you have added. That is the simple process for theoretical functions. So keep this in mind when you solve questions like this. Now, that is a quick recap of what we do for product rule. Let's quickly look at what happens in terms of the quotient rule. Again, the quotient rule is also very, very interesting and amazing in the fact that, unlike the product rule that deals with the multiplication of functions, the quotient rule now deals with a division of functions. How does this work? So, for the quotient rule, you will have y to be equal to u of x divided by v of x. Now, this is where the biggest change is, u divided by v. Now, the order becomes very, very important. The differential of this with respect to x will now be hold the denominator. So, v du dx minus numerator dv dx all divided by v squared, which is hold the denominator first, differentiate the numerator, minus hold the numerator, differentiate the denominator, then divide everything by the square of the denominator. The order becomes very, very important. So you must make sure you are picking your solutions with respect to the order they have been placed. Let's take a quick example. This time, let us find the differential of x squared divided by, or let me write it very, very interestingly. Let's find the differential of x squared e raised to power minus 2x. Yes, very beautiful. So this is what we want to differentiate. We want to differentiate x squared e raised to power minus 2x. Now, there is something very, very beautiful about this function. This function, in fact, is a function that we can decide to solve via product rule, or also decide to solve it via quotient rule. How does this happen? This is because of the fact that the exponential function, which is obviously raising a power, bears a very, very unique power. It is a power that is negative. Do not forget, in our journeys into indices, we talked about what happens when you have a negative power on your indices. Then you can rewrite it as a reciprocal. So we will proceed to solve this question using the two rules that we have. We will first and foremost solve it using the quotient rule, and then we will now proceed to solve this same question using the product rule. And then we'll see if there can be any similarities within the answers we get. Let's begin. So we write this is y is equal to x squared e raised to power minus 2x. And you can write this as x squared divided by e raised to power 2x. The negative power becomes a reciprocal. That is the law of indices. So you will see that every single concept we do in mathematics is in fact interrelated. So that means immediately that u will be equal to x squared, and then v will be equal to e raised to power 2x. Remember, order is important. The numerator is u, the denominator is v. Do not forget. So du dx will simply be 2x, and then dv dx, by the virtue of differentiation of exponential functions, will be 2 e raised to power 2x. Do not forget, it follows this process. Next, by quotient rule, we will have that dy dx, or let me write it in another form, y prime will be equal to denominator first, v u prime minus u v prime divided by v squared. This form that I've just written is still the same thing as this form. Du dx is the same thing as u prime, dv dx is still the same thing as v prime. Be able to discern different kinds of forms when you see them. That's why it's important to know the different ways in which you can write these differential symbols. So u first, that will be e raised to power 2x into u prime, which is 2x, minus u next, which is x squared, into v prime, which is 2 e raised to power 2x, all divided by e raised to power 2x all squared. Good. So we are making progress. We are making a lot of progress. And now we shall continue simplification. So now we have written out the formula. We have applied the formula. What's left for us to do is to simplify. So y prime will now be equal to 2x e raised to power 2x minus 2x squared e raised to power 2x divided by e raised to power 2x all squared. We can still go further in simplifying this. Of course, y prime will be equal to, you can factorize, 2x e raised to power 2x comes out into 1 minus x. Beautiful. So if you factorize, this is what you are going to have left in the numerator. Take a moment to sink in that factorization we have just done. 2x raised to power 2x is common to both sides. And if you expand, of course, you will get that back. And then you divide all this by e raised to power 2x all squared. What does this mean? It means that we can cancel one of the denominator by this e raised to power 2x, which is on top, so that we have y prime is equal to 2x y minus x divided by e raised to power 2x. Or better yet, as 2x 1 minus x e raised to power minus 2x. So you see what happens. We could have left our answer this way. We could have left our answer this way. We could have left our answer this way, or we could leave our answer this way. So it means that as you carry out various processes of simplifications, the way in which your answer will look like will continue to change form. You must be able to keep track of all these changes. Now, a task for you. Pick this question, the differentiation of x squared e raised to power minus 2x, and attempt to solve it via the product rule. Let us see if via the product rule, the answer you get will exactly tally with the answer we have gotten from the quotient rule. Take a few minutes to attempt to differentiate x squared e raised to power minus 2x using the product rule. I'm sure you have worked through solutions for that particular question. Let's see how to solve it together. Now, we are to solve this same differentiation process via the product rule. So let's see. So, using product rule, this form would have that, of course, let u be equal to x squared, let v be equal to e raised to power minus 2x. So now we are not going to be applying law of indices. We are just going to leave it as negative power that it is. Now, u prime would be 2x still. V prime will now be minus 2 e raised to power minus 2x. Still applying the standard rule for differentiating exponential functions. Then, by product rule, we will have y prime will be equal to u v prime plus v u prime. This means with u, which is x squared, v prime, which is minus 2 e raised to power minus 2x, plus v, which is e raised to power minus 2x, into u prime, which is 2x. Then, bringing it all together, you have minus 2x squared e raised to power minus 2x plus 2x e raised to power minus 2x. And then, you can simply factorize wherever possible. You can bring out 2x e raised to power minus 2x, and then on this side you'll be left with minus x, and on this side you'll be left with plus 1. And that will be all. And then you'll notice that what you have here is exactly what you have on this side. So it means that whether you use the product rule or you use the quotient rule, your end result must be the same. That is the simple notion or analogy that mathematics follows. Regardless of the method, regardless of the process, your final result must be the same. That is the proof that you are being correctly following whatever process you have followed. So if you had followed the quotient rule, yeah, you'll be getting the correct answer. If you have followed the product rule, yes, you'd also get the correct answer. It's now left for you to now see which of those processes is now the simplest process or the most efficient process for me to follow. Ideally, you'd find out that to solve a question like this, it's better for you to go through the use of the product rule instead of the quotient rule. The quotient rule is inherently longer in steps than the product rule. So you see a question like this, you know for a fact that you can solve it using the quotient rule, but it is better for you to go through the product rule, which brings you to the answer as fast as possible. You can also see the difference in the accuracy of the answer closest to the final result. We had to simplify this final result into this one, into this one, into this one. Whereas for the product rule, it brought us straight to this one in no time. Another analogy you find, of course, the fact that the product rule is much more efficient to use than the quotient rule stands to reason when you are writing a multiple choice or objective exam. For your theoretical exam, where your number of steps is very, very important, then you find out that the quotient rule will fit you more than the product rule. Because for the quotient rule, you can now go through more steps, which in essence means more marks allocated to you. when the marking process is carried out. So for the quotient rule, you earn more marks because of more steps you have compared to what you would earn for the product rule. But for the objective exam, where the focus is just on the final answer that you